welcome back to our grade 7 science tutorial. In regards with our topic for today, that is all about the percentage by mass composition of a solution. So let's start. One of the common way to express the solution in quantitative way is using a calculation. Prior to our discussion, we already defined the different types of concentration of the solution in accordance with its saturation. In this way, in expressing the composition of solution, it determines the properties of solution relative to the proportion of solute and solvent, by which it's a measurement or a measure of concentration of a solute in a solution. It is expressed as the percentage based on the mass of solute in comparison to the total mass of a solution. The percentage by mass in solution composed of a formula. This formula is equal to the percentage by mass in weight of a solution, which is equal to the mass of solute over the total mass of solution multiplied to 100. So this is our formula that we're going to use in our calculating or expressing our solution in a quantitative way. So let's begin. Okay, so there are three types of solution based on saturation. The first one is what we call unsaturated solution. The second one is what we call the saturated solution. And the last one is the supersaturated solution. We can define this solution in accordance with the amount of solute present on them. We all know that solution are composed of two. Solution or a homogeneous mixture composed of two basic components, and they are the solute and solvent. Now, solute and solvent compose of a what we call solution, and the number of solute depends on the type of solution that we can determine. First, for example, if we have unsaturated solution, we all know that there is a less solute compared to the solvent. Solvent is water, for example. Since there's a less solute in the solvent, a solvent occupies more solute, a space for more solute to be dissolved. In comparison with the saturated solution is equal amount of solute and solvent. So there's an equal amount of solute and solvent. While the supersaturated solution composed of a greater amount of solute compared to solvent. Okay, so there's a greater number or amount of solute in compared to our solvent. So this is our premise. Now, we're going to solve a problem that expresses this type of calculation, and we will determine whether the solution is saturated, unsaturated, or supersaturated solution. So let's all begin. Take for an example. Our sample problem is, if you have a solution of sugar, a sucrose, for example, as a C6H12O6 in water, the solution contains 200 grams of sugar and 100 grams of water. The solubility of sugar at this temperature is 180 grams per 100 grams of water. We need to determine the mass concentration of solution and what type of solution it is. So let's all begin with our process in solving the problem. First is by providing a what we call given. What are the different given data in our problem? So in our given, we compose of 200 grams of sugar and 100 grams of water. So we have 200 grams of sugar, 200 grams of sugar, and 100 grams of water. So since solution composed of two, we need to determine which among them is the solute and the solvent. Sugar, of course, is what we call solute, and water as a universal solvent. Out of this given, we need to find out the unknown or what is being asked in the problem. In this problem, we are asked to determine the mass concentration or mass composition of a solution. This is also equal to this one. And it's only an abbreviation. And also, we are asked to determine the type of solution. So this is our unknown. This is what the problem is asking for us to solve it. Next, formula. So the formula in solving the mass concentration composition by mass of a solution is that we need to determine the mass of solute all over the total mass of the solution and multiply by 100. So this is our formula. And to solve with that, we need to ask for the solution. So we need to plug in the given value to the formula. Okay. So the mass composition is equal to the mass of solute, which is 200 grams of sugar divide by 100 grams of water. Tama? 200 of sugar and 100 grams of water. So we have 200 grams of sugar plus 100 grams of water. Why? Because solution, we all know that solution composed of two. Solute add to a solvent. That's why this one is equal to the solution. Okay? Multiply this one to 100 to make it as percentage. And the answer is, using our calculator, okay. Using our calculator, the division sign, we have 200 all over 200 plus 100 grams of water multiply to 100. What is the answer? Execute and format. Standard. What is the change here in the calculator? Answer. Change. Calculate tools. Ulit. So we have 200 plus 100 multiplied to 100. We have 66.67%. Now, since we have 66.67%, what type of solution it is? So this is our answer. Sorry. If we have 66.67%, then it is a saturated, unsaturated, or supersaturated solution. So in comparison to 100 grams, or the solubility of sugar at this temperature is 180 grams per 100 grams. And the concentration of this solution is only 66.67 to 100 grams or 180 grams per 100 grams of water. So the concentration is only 180. We all know that this percentage, 66.67, is less than the solubility value or solubility index given with this problem. So thereafter, there's a less solute given in the concentration. And this one is the unsaturated solution. Because in accordance with our indexes, 180 can be dissolved in 100 grams of water. We have 100 grams of water in this example, and only 66.67% is being dissolved. So there's a more space pa in between with the index value or solubility index given or provided with us. And this solution is unsaturated solution. Now, I want you to try answering our practice problem number 1. You have a solution of salt or NaCl in water. The solution contains 90 grams of salt and 10 grams of water. The solubility of salt at this temperature is 36 grams per 100 grams of water. I want you to determine its composition and its solution type. Okay? Thank you very much, everyone.